In our last video, we used the rational roots theorem and our calculator to find the zeros of a polynomial. And we were lucky because we happened to find all the zeros in our table. All the zeros were rational zeros. However, sometimes you won't have that, and in this case we won't. If you don't find all the zeros in your list of rational zeros, it means the remaining ones are either imaginary or they're irrational. And so what we'll need to do is well, something else to find those. And so let's take a look how that process is going to work. So right off the bat, I can tell that this problem is going to have 4 solutions. And I've kind of already given away the secret. We're not going to find all 4 of them in the list this time. And so what we'll need to do is we'll start with making our list, find as many as we can, and then use synthetic division to get this down to a quadratic. At that point, we can then find our remaining irrational or imaginary zeros. And so let's start out with the rational roots theorem. We need to make a list of our possible rational zeros. So take the factors of 12, which are, of course, 1, 2, 3, 4, 6, and 12. All those numbers can be divided into 12. And divide that by the factors of your leading coefficient, which is 10. Factors of 10 are going to be 1, 2, 5, and 10. And so everything in that top list needs to be divided by everything in the bottom list. And so I'm going to get a very long list of possibilities. Let's take 1 as our first denominator. So that's going to get me obviously the same list. So 1, 2, 3, 4, and 6, and 12. Next up, let's make 2 our denominator. And remember, you don't want to include any repeats. So if you have something, don't list it twice. 1/2 I don't have. 2 over 2 I have. 2 over 2 is just 1. I would need 3/2. I would need, actually that's it, 4/2, 6/2, I already have all those. So next up, let's use 5 as our denominator. These are all the possibilities, and we're going to have to test every single one. So get ready for some fun. 2/5, I need that one. I'm going to need all these, I think, most of them. 3/5, 4/5, 6/5, and 12/5. I need all those fifths. Okay, so those are all possibilities. Last up, 10 is my denominator, so I need 1/10, 2/10 I don't need, 3/10 I need. 4/10 I don't need, 6/10 I already have that, 12/10 I already have that in simplified form. So I get a very long list of possible rational zeros. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, but not really 16. I've really got 32 possibilities because I've got the plus or minus version of each of those. And so at this point, what we need to do is test them. So using your table, I'm going to have you guys do this part on your own. Using your table and the ask feature, I want you to one by one plug each of these in and find out how many actually work. It's going to work if you get a y value of 0. If you need help with that, go back and watch the previous video. I showed you guys how to do it. Otherwise, I want you guys to pause the video and find those 2. If you let the video play through, I'm just going to tell you what they are, but that's no fun. I want you guys to test it for yourself. So pause the video, test all 32 of those. If you can find all 4, you're done with the problem. Sadly, you're not going to find all 4. There are 2, though, that you should find. So try that now. Alright, hopefully you've done that. Otherwise, if you're cheating, shame on you. But the 2 zeros you should have found were -1/2 and 3/5. Those are the only 2 that work. And so at this point, we're missing 2 of them. The remaining 2 are either irrational or imaginary. Either way, we're going to find them using the synthetic division process. So here's what I want to do. Pick one of those 2 numbers to start with. It doesn't matter which one you start with. Let's start with -1/2. And what I want to do is synthetic division with the original polynomial. So list out your coefficients. As we've always done, make sure you take note for anything that's missing and make sure it's in descending order. In this case, that's true. And synthetic division, hopefully you remember how to do it, since, because I'm going to go through it really fast. Since we know that -1/2 is a 0, I know my remainder should be 0. If it's not, something's gone terribly, terribly wrong. So again, synthetic division, I'm going to assume you know it, so I'm just going to kind of go through and do it really fast. So -5, -16. If you need to pause the video and do this for yourself, go ahead and do that. -34, 17, 24, -12, and as predicted, 0 at the end. I like to cross it out. Okay? If you didn't get 0, then something's gone wrong. And so at this point, I want you to kind of pause and think about what we have. Since synthetic division drops your polynomial by 1 power, what we have right now is a cubic polynomial. We have 10x to the third power minus 16x squared and so on. What I want to do then is I want to drop this by a power one more time. I want to get this down to a quadratic. Once I'm at a quadratic, I have the quadratic formula that I can use to finish this problem out. And so what I'm going to do is do synthetic division a second time right from where I left off. So take your second 0, the one you haven't used yet, the 3/5, and let's do synthetic division again. Okay? Once again, my remainder should be 0, otherwise something has gone horribly wrong. So don't do this from the original polynomial, do this from where you left off. You're kind of whittling it down to x squared. Every time you do synthetic division, you get down 1 power closer to x squared. So the 10 will drop straight down. If you need a calculator, go ahead and do it. If it's easier, make 3/5 0.6 and do your synthetic division. Pause the video if you need to, otherwise I'm just going to go through this fast because it's not a synthetic division video. I don't really care about that right now. So negative 40, and then that's negative 24. And so once again, I get a remainder of 0. Okay, so take a look at what we've done. We've done synthetic division twice, meaning this polynomial we have is now x squared. So this is 10x squared minus 10x, and then minus 40. Because I've now finally got this down to a quadratic, at this point, these problems are so long, at this point, I'm just going to use the quadratic formula program I have on the calculator. If you don't have that program, then I would ask me for it. That's a weird sentence. I would ask me for it. But get the program from me, or, I mean, you can do the quadratic formula by hand. It's just these problems are long enough the way they are. Doing this will get you your remaining 2 zeros. So I've done that in my notes already. You guys can pause the video and try that yourself. But with the quadratic formula program, I got the final 2 answers. 1 plus or minus the square root of 17 over 2. Notice it's irrational. That's why it didn't show up in my list of possible rational zeros. That list only shows me what would be rational. This is irrational. We would do the same thing if our answers were imaginary. They wouldn't show up, and so we'd have to do the same process to find the imaginary. So that's 2 of my zeros, and then if I want to list them all in the same place, my other zeros that I found from the list were negative 1/2 and 3/5. So there is all 4 zeros to this polynomial.